Welcome to the DIY Honda Garage channel. The DTC P0453, or Diagnostic Trouble Code P0453, refers to a fault within the fuel tank pressure FTP sensor circuit of the Honda Civic models from 2011 to 2015. This particular code indicates a high voltage signal issue from the FTP sensor, which is a crucial component in managing the evaporative emissions control system. The FTP sensor's primary function is to monitor the pressure within the fuel tank to ensure that it operates within the designated pressure range, which helps in preventing fuel vapor release and ensuring efficient engine performance. Essentially, the sensor sends voltage signals to the engine control module, ECM, providing real-time data about the tank's conditions. When the ECM detects a voltage reading that is higher than expected, it triggers DTC P0453, alerting technicians to potential faults in the FTP sensor or related wiring. This guide will help diagnose and troubleshoot the P0453 code effectively. The error associated with DTC P0453 involves the fuel tank pressure FTP sensor, which plays a vital role in monitoring the pressure of fuel vapors within the fuel tank. Positioned near the fuel tank, this sensor continuously sends pressure readings to the engine control module, ECM, facilitating accurate fuel management and minimizing vapor emissions. The FTP sensor operates by changing its voltage output based on the pressure sensed in the fuel tank. Typically, a voltage reading of approximately 4.7 volts or more signifies a high-pressure state, which could indicate a fault within the sensor circuit and is the basis for the triggering of DTC P0453. Understanding the exact location and role of the FTP sensor is crucial for diagnosing potential faults in the emission system and for ensuring optimal vehicle performance. Several factors can contribute to the triggering of DTC P0453. The most common cause is a faulty FTP sensor itself. If the sensor is defective, it may send incorrect voltage readings to the ECM, resulting in high voltage signals. Additionally, issues with the wiring associated with the FTP sensor can produce similar symptoms. Wiring that is frayed, broken, or improperly connected may result in erratic voltage readings, leading to the DTC being set. Bad connections, particularly at the junction of the FTP sensor and the ECM, may also interfere with the sensor's ability to communicate accurately. Each of these potential causes needs to be systematically checked and verified during the troubleshooting process to isolate the specific fault. Vehicles exhibiting DTC P0453 typically demonstrate a few noticeable symptoms, most notably the illumination of the check engine light, CEL. This warning signifies a fault detected, urging the driver to address the issue. In addition to the CEL, drivers may also experience poor fuel economy, characterized by an unexpected decrease in miles per gallon. The fluctuation in fuel pressure readings can disrupt fuel delivery, leading to rough engine performance, where the engine may misfire or operate inefficiently. These symptoms collectively point to the potential for issues within the evaporation system, requiring immediate attention to prevent further damage and restore optimal vehicular function. The first step in troubleshooting DTC P0453 involves preparing the vehicle and diagnostic equipment to evaluate the status of the FTP sensor. Begin by turning the ignition switch to the on position or pressing the engine start-stop button to activate the electrical systems. Using a Honda Diagnostic System HDS tool, clear the existing DTCs to reset the system. Once cleared, turn the ignition off and remove the fuel fill cap, which helps to eliminate any possible pressure buildup that could affect the readings during testing. After removing the cap, return the ignition to the on position again, allowing the HDS to gather data on the FTP sensor's reading. Optimally, the output should indicate around 7.3 kPa, or a voltage over 4.7 volts, to signify proper sensor function. This step establishes a baseline for further diagnostics. In the second troubleshooting step, the engine must be started and maintained at an engine speed of 3,000 RPM while idling without load. This process ensures that the engine is operating at a stable condition, which helps enhance the reliability of the diagnostic results. As the engine runs, utilize the HDS tool to monitor the onboard diagnostic OBD status concerning DTC P0453. If the HDS indicates a status of failed, it means the previously recorded fault can be replicated under the same conditions, indicating a malfunction that must be addressed. Conversely, if the status shows past or intermittent failure, the system may be functioning correctly at the moment. Therefore, further investigation is needed to look for poor electrical connections or loose terminals within the FTP sensor circuitry. To narrow down the source of the fault, the third troubleshooting step involves disconnecting the FTP sensor 3P connector. Once disconnected, it's essential to utilize a jumper wire to connect terminals A and B within the FTP sensor connector. Specifically, connect terminal A, white wire, to terminal B, black wire. This temporary bridge allows for testing the FTP sensor circuitry without the sensor itself affecting the readings. After establishing the jumper connection, turn the ignition back to the on position. With the HDS tool, measure the FTP sensor output once more. A reading of approximately 7.3 kilopascal, or a voltage of 4.7 volts or higher, would indicate that the FTP sensor itself is functioning correctly. If not, it's necessary to replace the FTP sensor. In the fourth troubleshooting step, focus shifts to evaluating the P-tank line that connects to the FTP sensor. Before doing this, ensure the jumper wire from the previous step is removed, followed by turning the ignition to the on position. With the FTP sensor disconnected, test the voltage present at test points established within the wiring harness, specifically between test point 1, black wire, and test point 2, red wire. This test condition should be checked with the ignition on. You are looking for a voltage reading of around 5.0 volts. If the voltage reading falls within this acceptable range, it indicates the P-tank line is operating correctly, allowing you to proceed to the next step. If not, further diagnostics are required, targeting possible interruptions in the wiring. The fifth step of the troubleshooting process involves verifying continuity within the P-tank line. Begin by ensuring that the ignition is turned off before jumping the SCS line within the HDS. After this, disconnect the PCM connector A, feature a 51-pin configuration. At this juncture, connect terminal A, white wire from FTP sensor, to body ground with a jumper wire. Following this setup, check for continuity between the specified test points located within the wiring harness to see if the P-tank line is complete. It is important to test under lock, 0, or off conditions, ensuring the FTP sensor connector remains disconnected. Successful continuity indicates that the P-tank wire is intact. If a fault persists, addressing issues within the wiring between the PCM and FTP sensor is necessary. In the sixth and final troubleshooting step, the focus turns to examining the SG6 line for continuity. As with previous steps, begin with the ignition in the lock, 0, or off position before jumping the SCS line using the HDS. Disconnect the PCM connector A once more to prepare for a similar continuity test. Using a jumper wire, connect terminal A, black wire of the FTP sensor 3P connector, to body ground. Check for continuity between the specified test points, ensuring that the FTP sensor remains disconnected and that you're working under off conditions. If continuity exists, it confirms that the SG6 wire is functioning properly. If DTC P0453 clears upon updating or substituting the PCM, the troubleshooting is deemed successful. Otherwise, attention to any open wires in the SG6 line will be required. To ensure that the repairs made have effectively resolved the P0453 error, it is essential to perform a final verification. First, confirm that the vehicle's diagnostic trouble codes have been cleared successfully using the HDS tool. This step ensures that previous fault codes do not reappear without addressing underlying issues. Following this verification, a test drive of the vehicle is necessary to observe whether the symptoms associated with DTC P0453 persist. Focus on checking for any occurrence of the check engine light and monitor for improvements in fuel economy and engine performance. If multiple drive cycles occur without reactivation of the DTC or any symptoms like rough idling, the repair can be considered successful. Preventive maintenance is crucial to the ongoing reliability of the FTP sensor system and can help avert future occurrences of DTC P0453. One proactive measure is to regularly inspect the wiring harness and connectors associated with the FTP sensor for any signs of wear or damage. Ensuring connections are secure can prevent potential intermittent faults. Keeping the powertrain control module PCM updated with the latest software helps maintain optimal performance of the vehicle systems and reduces the chances of error codes arising from software deficiencies. Lastly, replacing an aged or damaged fuel filler cap can prevent vapor leaks and ensure that pressure conditions in the fuel tank remain stable, further promoting efficiency in operation. In conclusion, DTC P0453 signifies a high voltage situation in the FTP sensor circuit, which can stem from various causes, including a faulty sensor or issues within the wiring. A systematic approach to troubleshooting, including verifying sensor output and electrical connections, is essential for accurately diagnosing the problem. Following the detailed steps provided ensures that any fault can be effectively pinpointed and rectified. It is also essential to engage in regular preventive maintenance practices to reduce the likelihood of recurrence. Proper verification of repairs and maintaining an updated system software can ensure the longevity and efficiency of your Honda Civics evaporative emissions system. Please like and subscribe to the channel. See you next time.